Welcome to NIOS live classes. Subject Science and Technology. Class 10th, book number 212, module number 2, Matter in our surroundings. Lesson number 2, Matter in our surroundings. Part 4. Previously, we learned part 3, and now before moving ahead, let's recall what we learned in part 3. Learning outcomes. First, after studying this lesson, you will able to know about homogeneous and heterogeneous mixture. And second, solution and its concentration. Outcomes. After study this part, you will able to learn and can calculate the percentage composition of a solution and can describe the properties and uses of suspension. And also can describe the common method used for separation of mixtures or purifications of a substance. First, we will know the concentration of a solution. Concentration shows the amount of solute present in a solution. Concentration means how much solute is dissolved in a certain amount of solvent or solution. It tells us how strong or how dilute a solution is. Concentration means how much solute like sugar or salt is mixed in a solvent like water. For example, if you add a little sugar to a water, the drink is light. And if you add a lot of sugar, the drink is strong and sweet, that how much is called concentration. There is a photo on the screen. We have studied that less solute means light drink or low concentration. More solute, it means strong and sweet or high concentration. In short, concentration means how much solute is mixed How we measure concentration? In 100 gram of a solution, how much of it is solute? Let's explain or understand with an example. There is a formula showing percentage of solute equals to mass of solute and upon mass of solution multiply by 100. Whereas mass of solute means the substance that is dissolved, like sugar or salt, and mass of solution is solute plus solvent. Now let's put some digits in that formula, like mass of solute, which is salt, is 10 gram and mass of solvent, which is water, is 90 gram. So mass of solution will become 10 plus 90 equals to 100 gram. And now we put that 100 gram value in our formula. So we get the answer 10% salt solution. What is happening in this example? We are making salt solution which becomes from salt and water. Solute, it means the substance that gets dissolved. Here it is salt and mass 10 gram. And solvent, the substance that dissolves the solute. Here it is water whose mass is 90 gram. So how we get the solution? Adding solute into an solvent. So total mass we get 100 gram. short, we can say that concentration tells us how much solute is present in solution, like salt or sugar. If more solute is mixed in small amount of solvent, so we get high concentration, which is strong solution, and if less solute is mixed more solvent, we get low concentration. Now let's do some activity for our better understanding. Activity 2.4. Here the activity is make a solution of sodium chloride, in short we call it NaCl, in water with a known concentration of 10 gram per liter by mass. Take a graduated flask and fill appropriately half with distilled water. Weigh out 10 gram of sodium chloride, which is the solute, and now carefully add the sodium chloride into the water in a container. And after adding, gently shake the container to dissolve all the sodium chloride. And after mixing them, add more distilled water to make up the volume of the solution to exactly the 1000 ml, and mark on the neck of the graduated flask. Finally, shake the flask carefully to make the solution uniform. Now, what is suspensions? A suspension is a mixture in which big particles of a solid or liquid are spread in another liquid, but they do not dissolve. Because the particles are big, you can see them with your eyes. And after some times, they settle at the bottom, as you can see on the screen. For example, fog happens when tiny water droplets are suspended in air. These droplets do not dissolve fully, they stay mixed in the air for some time, so for also a type of suspension. Now here is a question, why suspensions form? Some solids cannot dissolve in water properly. Some liquids don't mix with each other. These make heterogeneous mixture, which is mixed but not uniform anywhere. Based on particle size and mixtures are divided into First is colloids, which is medium sized particles. And second is suspensions, which is large particles like more than 10 nm, 1000 nm. It's time for a break. Welcome back to our classes. Now we will look the features of suspensions. In suspensions, there is a big particles can visible to eyes. It means particles don't dissolve fully. Particles settle down when the mixture is left undisturbed, and also mixture looks cloudy or muddy. Features of suspension as we have studied before. First is big particles, as you can see on the screen, can visible to eyes, and second is particles don't dissolve clearly, they will remain undissolved or settled on the ground. And in third flask, you can see particles settle down when the mixture is left undisturbed. And last, looks muddy. For better understanding, let's look at this example. We mix flour in water. When you mix flour with water, it forms a slurry, which is a suspension mixture. If it left still, like without touching or disturbing, the flour settles at the bottom. Second example, we can also see muddy water. Same, if we apply, like we mix water and soil or mud, so soil or mud's particle will float for some time and settle down after. Here's a picture, you can see suspension of soil and water before mixture and after settle down. Activity 2.5. Prepare a suspension mixture using materials available in your home. In it, material required: wheat flour, which is 1 cup needed, like 200 gram, and water. And third, a glass, which is 250 ml. And fourth one, a spoon. And now, how to do the activity? Firstly, take a clean glass and pour some water into it. Then add wheat flour to the water. Then use a spoon to stir the mixture well. And fourth one, after stirring, leave the mixture undisturbed for some time. And fifth step, observe the mixture carefully and write your own observation. And sixth, then decide whatever the mixture is, a solution or a suspension, and write one reason for your choice. Here is the picture explanation of that separation of mixture. When we clean rice or wheat by removing stones, dust or other unwanted things, we are actually separating a heterogeneous mixture using simple physical method. Even though making mishri, which is like a sugar crystals, is a type of separation, in this process sugar is separated from sugar water solution when water evaporates. home and in industries, we separate different mixtures, both homogeneous and heterogeneous, for many purposes. For example, we can get back salt or sugar from water by heating or evaporating the water. After heating water, we can get salt or sugar. Different mixtures need different separation methods. The method depends on two types, which is first the type of mixture and which substance we want to collect. Here are some methods of separation. In those methods, there is one method which is separation by using a separating funnel. When we have a mixture of two immiscible liquids that do not mix like oil and water, we can separate them using a separating funnel. It's time for a break. Welcome back to our classes. Now we will look how separation of oil and water using separating funnel. How it works? First, pour the mixture of the two liquids into a separating funnel. And leave the funnel undisturbed for some time. Slowly, the two liquids will form two separate layers. Because they do not mix, so the denser liquid, which is heavier liquid, settles at the bottom and the lighter liquid stays on the top. When the layers are clearly visible, open the stopcock, which is called tap, at the bottom. So first collect the bottom liquid, which is denser liquid, and then close the tap before the lighter liquid starts coming out. And where is it useful? Where can we use that funnel? This method is very useful in industries, especially to separate liquids like oil and water. Next is separation by evaporation. Evaporation is a method used to separate a solid which is solute from a liquid which is solvent in a solution. And how it works? When you heat a solution, the liquid which is solvent slowly changes into vapor, and after heating they disappears through the vapor. Then the solid which is solute does not evaporate, so here it is left behind as a solid or powder. For example, we can take the example of salt separating from the sea. Salt is separated from sea water in large shallow beds near the seashores. The sun heats the water evaporates and salt crystals remain on the bottom. There is a picture on the screen explains the separating salt from the sea water. There are some important points. First, safety while heating. If solvent can catch fire easily like alcohol, do not use a flame like a candle or burner. Instead, use safe heating method, which is electric heater or water bath or oil bath. This prevents accidents and fire. What happens in evaporation? When you heat a solution, the liquid which is solvent turns into vapor and goes away, and the solid which is solute is left behind. So you get only the solid, not the liquid. For example, the most easy example, which is salt water. After heating them, water evaporates and salt remains as a solid on the bottom. We can play this example or activity in our science lab using flask. We have completed this part. Thank you for paying attention.